All right, let's take a minute now to have a look at an example. But before we look at the example, please note that there are three buckets under which we can categorize the things that we are doing inside of this module. One, we are concerned about data storage. Two, we are concerned about data manipulation. And three, we are concerned about creating data models. Whenever we create a class, we are creating data models. And inside of these data models, we are concerned about storing data effectively and also efficiently. And the other thing that we are concerned about is how do we manipulate that data? And by manipulating the data, we mean how do we change the data? How do we update the data? How do we process the data? So these are all terminologies that we can use synonymously. Let's start at line 9. In line 9, we are making use of a library. And the library in this case is called IOStream. Now, it's important that we make use of the libraries because the libraries will indicate the kind of operations that we have access to within the program. So the developers would have created these libraries and they would have packaged different operations inside of these libraries. In this case, IOStream is the library that contains the operations that allows us to do input and output. So remember, we were looking at line 9. We were looking at ensuring that we have access to the IOStream library. Now, going down, the IOStream library will give us access to commands such as cout. So if you have a look here, you realize that we are making use of some cout commands. And what cout does, it means console output. And we are putting information onto the console or onto the screen. So in lines 24, we are displaying the value radius. And then after that, so the first part here, we are displaying radius. Then after that, we are displaying the content that is found inside the radius variable. Or better yet, inside the radius property. Remember, we had said earlier that once a variable is inside of a class, we call it a property. So this is a class. The class is ball. And inside of the class, we have created this variable called radius. So this variable is now a property. It's a property of the ball class. So we are displaying the content of the property radius. And before we display that value, we are displaying some information that indicates what the value is. Now, the other thing that you want to bear in mind here is that we are preceding the cout command with the std keyword followed by 2 colons. And we will come back to this again in a later video to see how we can kind of clean up the code so it looks a bit more appealing. So line 9, as we mentioned, takes care of ensuring that we have the necessary libraries. And bear in mind, we can have one or more libraries within a program. On line 11, that's where we are starting to create our blueprint. Remember, the class is the blueprint, or put it another way, the class is the data type, the non-primitive data type created by the programmer. So the keyword is class, and following the keyword, we have the name of the class, which in this case is ball. Now, the class needs to have a begin and it needs to have an end. So we need to know where the class begins and where it ends. On line 12, we have our opening curly bracket. We call this the begin. And on line 35, we have the ending curly. That's known as the end. So between the begin and the end, all the information that we find inside of that are going to be associated with the class. Please note that in C++, we need to terminate the class with a semicolon. So it's begin, end, semicolon, and then we now put whatever we need to put inside of the class. Now, there are going to be two sections within the class. Remember, we had said that a class has properties, which are the features or the data, and the class also has methods, which are the operations. So it is customary to place the properties under the private section. Line 13, there's a keyword called private that ends with a colon. That tells us that we are now in the private section. And in the private section, we're going to put our properties. In this case, we have a property for radius, one for area, one for has air, one for color, and one for visible. Please also note that just in terms of illustration purposes, we're making use of the 5 basic data types that we would have spoken about earlier. So we have radius being int, that's integer. We have area being float, that's the real value that can hold decimal points. We have has air being Boolean, that can hold true or false. We have color being char star, so that we can hold text values. And we have visible being char, so that we can hold just a single character value. Just by virtue of review, you will realize that we have listed the C++ data types right at this section, where we are saying that int is integer, float is real, bool means Boolean, char, we can store a single letter, a single symbol, or a single digit, such as 5, as we mentioned earlier. A letter can be like a B, and a symbol can be like the hash sign or the pound key. And char star is what we use to represent string. Remember that string is really a collection of characters which are combined together. Now, the concept of syntax becomes important because syntax means we are using some rules to write the command. If we look at English, for example, it has a syntax. There's a syntax that determines how a sentence is formed in terms of where we put the nouns, where we put the adjectives, the adverbs, and so on. Similarly, within a programming language, we need to know the rules that we're going to use so that we can create valid commands within the language. And one of the rules that we need to understand is the rule that allows us to create a variable. And the rule is very simple. It says we need to have the data type. We follow the data type by a variable name. Please note there's a space between the data type and the variable name. And then we terminate the command with a semicolon. So it's data type, space, variable name, semicolon. So on line 15, for example, we are creating a variable called area. And this variable can hold a floating point value or a real value. And we have terminated that line, that command, with the semicolon. So you can see that all these properties are really variables. Remember, properties are variables which are placed or which are found inside of a class. A key thing to bear in mind about a variable, though, is that it stores one piece of data. And if you look at the image here, the graphic is illustrating the fact that if we have data currently inside the variable and we want to put new data into the variable, then what we need to do first is to remove the old value or the old data. So the bucket, being the variable, can only hold one piece of data at any given instant in time. And this is a very, very important concept that you need to appreciate. So remember, a variable is a container for storing values, and we are saying here that a value is a single piece of data that is stored inside of that variable. So we have spoken about private section, which contains the properties, but we now also need to talk about the public section. So that's on line 20. Notice the keyword is public, and then there's a colon to indicate that we are now in the public section. And in the public section, we expect to find our methods. In this example, we have one method, starting from line 22 and ending at line 34. So we have a void for the return value type. If we look at the syntax down here for creating an operation or a method, the syntax says that there is a return value type. Then there's a function name. Then there's the open brackets or the parentheses, and inside of that we have parameters if necessary. There's a begin. There's an end that demonstrates where the function begins and where it ends. And within the function body, where it begins and ends, that's the function body, we will have a set of micro operations. And at the end, we have our return keyword followed by the return value. So let's use this syntax to understand what is happening for the show details operation. So the return data type or the return value type in this instance is void. And that is telling us that this function will not return or push out any output. Now, pushing out an output is different from displaying an output. And this is something that we will look at when we dive deeper into the whole concept of functions and methods. But for now, what we are saying simply is, if the function does not push out an output, then it means that we want the return value type to be void. And in this case, it's not pushing out any output. So the return value type is void. Following the return value type, we need to have the name of the function. The name of the function in this case is show details. Following the function name, we need to have the parentheses. And inside of the parentheses, we can have our inputs or our parameters. In this case, we are saying that there's no parameters, there's no inputs into this operation. Line 23 tells us where the body begins, and line 34 tells us where the body ends. We need to ensure that we have a body associated with each function. Now, within the body, we can have our micro operations. These are the commands that we want the function to execute. And the function is going to execute these commands line by line, meaning we would start at line 24, execute, then move to line 25, execute. And we will continue in that same pattern until we have exhausted all the micro operations, which are to be found inside the body of the function. We are making use of the cout command in this case, and the cout command, as we mentioned earlier, is displaying information. So we're displaying information for the radius, for the area, or visible. And these are all of the properties that we have so far up above: radius, area, visible. Note also that in each of these cases, we are printing multiple pieces of information on the same line. So each time we see the double less than sign, it means that we are printing a different piece of information using that single cout statement. So we're printing radius, and then we are printing the value of the radius because this is the variable. Once we see a variable name, then what we're actually doing is printing the content of the variable. And then we're also printing something else, which in this case is the \n, which is equivalent to printing a new line. On line 28, we are doing something slightly different. we're making use of a command, which is known as the if command. And what the if command does is it checks to determine if a condition is true or false. So we have a statement, and the statement inside the parentheses says, we're looking at the variable called has air, or the property called has air. We're looking to see if it is equal to the value true. And if it is indeed equal to the value true, then we are going to display the string inflated on the screen. So note, once we want to display string values need to be enclosed inside double quotes. So looking here, we realize that inflated is placed inside double quotes, just as though the value radius with the colon here is encapsulated inside the double quotes. So if the value in has air is equal to true, we want to print inflated, followed by a new line. Otherwise, that's what the else means. It means if the condition above is false, or if the condition above is not true, then we want to do something else. And in this case, we want to say, if has air is not true, then we want to display not inflated onto the screen, followed by a new line. And the final thing inside this method is we're displaying some text, color, and then we actually want to display the color that is stored. So remember, this is the variable. So at this point, we would be displaying whatever is being stored inside the variable color. So just in terms of summarizing some stuff that we would have covered already, an operation or a method is an action that can be executed by the computer. And we have placed the operations inside of the class. We're also saying that operations usually take in input, and then we convert these input to outputs, and we return the output. And that's what we are seeing down here when we have the return keyword followed by the return value. The return value would be the output that we want to push out of the function. And I'm using the word push to represent output going outside of the function. And I'm using the word pull to represent inputs that are being pulled into the function. So the parameters would represent the inputs that are being pulled into the function. The function will then make use of those inputs to generate an output. And once the output is generated, then that output is going to be pushed outside of the function by making use of the return keyword. We're also saying that the operations which are found inside of the method, we are going to call them micro operations or micro ops. And these micro operations can be printing stuff, it can be storing stuff, modifying stuff, or we can be comparing stuff. And we have kind of shown most of those inside this show details method. We have printed elements. On line 28, we have compared elements. So the only thing that we have not done here is to actually store elements and modify elements, but we will do that in short order. And we have said before that a function is another word that we can use in place of an operation. Remember, standardizing, we are saying that within a class, we have properties, which are the variables within the class, and we also have methods, which are the operations within the class. Right below, we have the main program that we had discussed previously, where we have created the object, my ball, using the class or the data type ball. And then we are making use of the show details method. Remember, show details is a function. or an operation inside of the class ball. So we're making use of the show details method, which is found inside of my ball. My ball is the object, and we are using the dot operator to get access to that show details command. And just in terms of the final thing, remember we are saying that an object is a variable that is created from a class. So my ball is a variable. It's a special variable that we have created from a class. And because we have created it from a class, then we call that variable an object. And we use the dot operator to provide access to all of the operations within the object.